This is Shakil Ahmed. In this tutorial, we will discuss the Wilcoxon Signed Rank Test, that is an alternate to the paired sample t-test, but the hypothesis is a little bit different. In this case, in null hypothesis, we assume that the two data sets are same, the two distributions are same, rather than saying the two means are same. And the alternative hypothesis says that the pre and post data has have different distributions. And we are just taking an example of material weights in teeth. This is data taken from dentistry studies, and we are just going to apply a Wilcoxon Signed Rank Test. So the Wilcoxon Signed Rank Test provides us the test statistics based on Z, although you can use the WS, the Wilcoxon statistic directly using Wilcoxon formula, the table, uh, but mostly we use the Z approximation using the WS statistics, that is the sum of the ranks, uh, which may be the uh, positive ranks or the sum of the negative ranks. Which one is the smallest? We take the smallest of absolute value of the sums. We have two rank sums, one for positive ranks and one for negative ranks. We will keep the smallest of the two rank sums. So this is the formula of this statistic, and this is the standard error. This is the mean, and n is the number of observations. So let's do in Excel. We first need to find the difference, whatever you want to find, b minus this second observation minus first, or first observation minus second. It's up to you. We can just find the differences. Just drag down. These are the differences, and then take the absolute of the differences. Absolute of the differences, and you will get the absolute values, and then rank the absolute values again using the rank command, rank average, and then this is the value, and we are ranking in the range. We just using the dollar sign to fix the value to the two ranges, f and 2, and then f. I think we have 25 observation, then it should be 26. You can just check. We have 25 observation. So we are just leaving first row as the name of the variable. And then the order is ascending order. So you need to write 1. If you want to rank in descending order, then put it as 0. So this is the rank for first observation, and you can get the ranks for the rest of the observations. And then sign rank. You just give the sign of what? Sign of these differences. You are basically again categorizing the ranks in negative and positive based on these values. If there are zeros, you can just skip that, or you can write 0. So we have positive value, positive set, positive differences, set of positive differences, and set of negative differences. And we will find the rank sums. So these are the results already I have written. Uh, how many observations in the negative rank? You can just find using the count if command. Just select and Then the criteria is -1. This is the negative ranks and the positive ranks found if, so you can see documentation as well, but I'm just dragging the data. And then what is the criteria? Criteria is 1. And there are no zeros, so it's just 0. And total is 25 observations. And now we need to find the sum of positive ranks and sum of negative ranks. So we can just define using sum if command, or you can use sum ifs command. It's up to you. You can use bots. Then select the range in which you are applying the sum, and then criteria range, that is we are categorizing based on the signs. We are finding this rank sum for the positive signs and corresponding to the negative signs. This is for negative sign. So I'm just setting the criteria as -1 and then close. This is the sum of rank is 122.5. And then again, I'm just copying these commands. You can just copy and then uh, right here and just change it to +1. This is the sum of positive ranks. And now uh, you will find the test statistic Z. So we need to find the number of observation, that is 25, and WS is the Wilcoxon statistics, that is the smallest of the two rank sums. So it's 122.5. And what is the expected value of the rank sum? That is uh, 25 into 25 plus 1. That is 26 divided by 4. This is the mean. And what is the standard deviation? That is square root of n, that is 25, staring 26, and then staring 2 into 25, that is 50, plus 1, 51, and divide by 24, and then square root close. So this is the standard error. And now we can find the z statistic using the Wilcoxon value minus the mean and divide by the standard error. So it's minus 1.076, and we can compare it to the critical value of the z, that is 1.96 if we take alpha as 0.05. So it has uh, it does not provide evidence of significant difference between the material weights in the two groups. And you can find the p-value using normal distribution. Normal, this is basically 1 minus normal distribution. This is standard normal distribution. You need to normal distribution. I think standard normal is okay, as this is the z value. So you can just find this value, but you need to use the absolute of this value, as this is negative. Basically, we are finding the area above the z statistic and then subtracting from 1. The below the z statistic and subtracting from 1. Basically, we are going to find the area above the z statistic. So the mean is 0 and the variance is 1, and cumulative is true. So the p-value for one-sided and for two-sided, you can just multiply it by 2. You get the 2-10 p-value. So, and the conclusion is there is no significant difference in the material weights of the uh, two goods. That's all about Wilcoxon Signed Rank Test. Thank you.